We all have a classical computer, like Windows or Mac, and they are the normal computers we use. Now, those classical computers uses binary or machine language to operate and understand, because it's their language, this is how they communicate. While binary numbers are only 0 or 1, and they are bits, and a bit can only be 0 or 1. But this binary format allowed computers to solve some kind of problems, but not all of them, simply because they were unable to solve it, or it will take them decades to give us a valid answer. But thanks to quantum physics, which describes the behavior of atoms and particles like electrons and photons, computers are getting better and better, which we all know right now as quantum computers. Quantum mechanics is the field of physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles. Quantum computers are devices that perform quantum computation, which is a type of computation that can harness or use the phenomena of quantum mechanics, such as superposition, interference, and entanglement. Those devices are able to offer outstanding results in terms of solving a problem, and they are able to revolutionize our future and can perform high-speed and accurate molecular simulations, making them an essential tool for accelerating the discovery of new materials and can affect many sectors like engineering, medicine, finance, and more. Before we dive in, I want you to know some general information. Quantum computers use qubits or quantum bits that can be 0 and 1 at the same time, while classical computers uses bits like 0 or 1. A single qubit can have two states, 0 and 1. Two qubits have 4 states, which they are the following. But maybe you are working on 10 or 20 or n qubits. How can you know how many states it has? Well, you'll say 2 to the power of n, and n represents the number of qubits. So if I'm working with 3 qubits, 2 to the power of 3 will give me 8. So 3 qubits will have 8 states. The concept of superposition is when particles can be in different states at the same time. Imagine those two shapes, a circle and a square. What will happen is, I will merge them together. What we see is that these shapes are on top of each other. This is the same concept of superposition. We know that modern computers use bits like 0 or 1, but quantum computers don't do that. They use qubits or quantum bits, which can represent a combination of 0 and 1 with some probability of being 0 and some probability of being 1. As Shohini Ghosh said on a conference on the TED Talk, that the identity of a quantum computer is on a spectrum. So it can be 80% 0 and 20% 1, or 45% 0 and 55% 1, and so on. So in quantum computing, if we use the concept of superpositioning a qubit, the quantum computer can read 0 and 1 at the same time. As you can see in front of you right now, I've merged the 0 and 1 together, so the outcome is both 0 and 1 at the same time. This is what will happen in the concept of superposition. That means every operation on a qubit is done on both values at once. This property of the qubit to be in a superposition of two states at the same time is what allows quantum computers to perform specific operations or solve certain problems at a faster rate. Now imagine superpositioning 100 qubits or millions of qubits. Just imagine how many states at the same time it could be in and how strong the processing power will be. It is possible to teleport information from one location to another without physically doing it. This is where we will talk about entanglement. Entanglement is a relationship between two superpositioned particles or qubits. Because they are strongly correlated, obtaining information about one state will give immediate information about the other state, no matter how far apart these systems are, and that creates a channel for teleportation. Let us say you place this red shape in Earth and a blue one in Saturn. They will show the same outcome every time no matter the distance. So when you say two qubits are entangled, changing the state of one affects the other qubit. That means if you have two qubits, 0, 0, if we change the state of the first qubit, which is 0 to 1, the second qubit, which is also 0, will change to 1. And this is entanglement. But why is entanglement so important? Well, what this phenomena does is, it increases the speed of communication of qubits in quantum computers, which makes them faster than any classical computer. Also, with superposition and entanglement, quantum computers can store enormous amount of information. Classical computers use logic gates to operate, which take an input and produce an output. Like if we are using the AND gate, we give an input of 0, which represents false, and another input of 1, which represents true. Then the output should be false. But why exactly? Because with AND, both input should be true in order to get an output as true. But if you had the OR gate and the inputs were 0 and 1, we will get 1. Because with OR, either one or both of these inputs should be true to get true in the output. But quantum computer gates are pretty different. These are the gates in quantum computers, which I got from Wikipedia. Now, quantum gates are basic quantum circuits that operate on a small number of qubits. Now, to keep everything simple, because it is not a quantum gates tutorial video, I'll try to explain the idea by giving you an example using the Pauli-X Gate. Now, the state of a qubit is represented by a single column matrix. Like the qubit is at the 0 state, which is written in this manner, has the matrix form of the following: 1, 0. But if it was at the 1 state, it will have the matrix form of the following, which is 0 and 1. Now, what will happen if we add those two states together, like the 0 state with the 1 state? We will obtain the following matrix form: 1, 0, 0, and 1. Now, those weird notation over here reminds us or tells us that we are working with vectors. Now, if I go ahead and use the Pauli-X gate on those two states, what this gate will do exactly is it will reverse the 0 state to 1 state and the 1 state to 0. So right now, let's go ahead and add those two states. We'll get the matrix format of the following, which is 0, 1 and 1, 0. And as you can see, what the Pauli-X gate will do is it will interchange or reverse the qubits. Now, to see the effect of the gate on a qubit, like let us try the 0 state, we should do some calculation that will reverse the 0 state to 1. Well, we know that when we are working with vectors, it is possible to make use of the scalar product method or the dot notation method. So if I want to go ahead and try it out with the 0 state, I'm going to say something like this: x and followed by the 0 state. Right now, let us go ahead and do some calculations. Now we know that the X gate will give us an output of 0, 1, 1, 0. And the 0 state has a matrix form of 1, 0. Now let's go ahead and use the scalar method. We'll go ahead and do 0 dot 1, this 0 with this 1, okay? And then we'll go ahead and add it with 1 and 0. And let us put it in the matrix form. Right now, let's go ahead and say 1 dot 1, this one and this one, plus 0 and 0, which is this one. Now if we go ahead and do the calculation, 0 and 1 is 0, plus 0 of course will give us 0, and 1, 1 is 1, plus 0 it's 1. So as you can see, what this reminds you is the state of 1. So this is how the 0 state will get reversed to the 1 state. Now this is the Pauli-X gate, and there's a lot more gates than this one. But because it was simple to explain, I wanted to show it to you. But if you want to learn more about quantum gates, there's sure a lot of videos about them that can help you with this problem. But what is the purpose of quantum gates? If you look at the logic gates of classical computers, they consider all the probabilities, one by one. Where in quantum gates, it runs all the probabilities at once, which makes quantum computing faster at solving problems. Now, quantum computers are still in their early stage of development. It is a hype, just like the early stage of the first classical computer, the ENIAC, which filled up the whole room. And for now, that's what quantum computers are doing. And here's a picture of Google's quantum computer and the CEO of Google next to it. But for now, we will wait and see where the advancement of technology will take us and how can it improve quantum computing. Now, thanks for watching. Make sure to subscribe for more tech-related videos. So now that you know that quantum computing is a technology that can eventually change the future. But there's 6 more technologies, like AI, brain-computer interface, and more. So check them out inside this video. Or if your classical computer is giving you problems such as crashes, you really need to know the reason of these crashes. So make sure to check out this video.